This is Calculus 10-2, verifying trig identities. More trig functions, make sure you have your unit circle ready with all of those trig functions, or you have your section 10.1 notes with you that have your trig identities on it. So, because you will need that a lot. So when they say verifying trig identities, here's what they mean. So they'll give you something that looks like this. So an equation, you'll have something on one side and something on the other. And basically the answer to the question that they're asking is, show me how to get from here to here, basically. So the answer is in the work that you show. It's not necessarily an answer. You're given the answer. You know that this is equal to that, but the answer is in the work that you show how to get from one to the other. So these are kind of like puzzles, and sometimes you start with one side and you're trying to figure out what's going on, and it leads you to a dead end, and you're just stuck, and then you just kind of have to start all over. So I've done that many, many, many times. I'll get to a place, or I'll get going on one side thinking that I'm headed in the right direction, and then I'll have to start over again. So that's what can make these slightly unpleasant, but just push through it. And here's some guidelines that help you to know what to do. So one thing you want to do is work with one side of the equation at a time. It's often better to work with the most complicated side first. So try the one that looks the ugliest first is what you're gonna start with. So on this equation, we would want to start with the left side because that looks a lot uglier than what the other side does. So number 2, look for opportunities to factor an expression, add fractions, square a binomial, or create a monomial denominator. You're going to want to factor things out and cross things out if you can. That will help reduce one side down. Number 3, look for opportunities to use the fundamental identities. That's when you're going to use that other sheet or your unit circle if you've got them all written on there. So you want to use those identities when you can. That's huge. Note which functions are in the final expression you want. Sines and cosines pair up as well, as do secants and tangents and cosecants and cotangents. So if those pairs are used together and they can help you reduce one side of the equation down, that's going to help significantly. If the preceding guidelines do not help, try converting all terms to sines and cosines. If everything else fails, switch it all to sines and cosines. I want to really note that there is more than one way to solve or to show that one side looks like the other side. One of you might use a Pythagorean identity where the other one, converts them all to sines and cosines, and you get the answer from there. So there's more than one way of verifying each one of these. Always try something. Even paths that lead to dead ends give you insights. So that's when I said you might end up going down one road and then just completely flop to a different idea, and that's okay. So this one they kind of walk us through. They give us kind of a hint as to how to start. So they want us to start with the left side first, from that guideline, the most complicated side first, and they want us to use a Pythagorean identity first. So a Pythagorean identity, I see, let's see, well, I see this guy right here can become a Pythagorean identity. So what we can do is secant squared theta minus 1 is, let's see where we're at, secant squared theta minus 1. Secant squared theta minus 1 would be the same thing as what tangent squared theta. If I subtract the 1 over to the other side, secant squared theta minus 1 is tangent. So what I'm going to do is I'm going to convert that to a tangent squared theta, and that's going to be over secant squared theta. Then they want us to use a reciprocal identity. So what I can do is reciprocal identity would be like, let's see, secant is 1 over cosine. So I've got 1 over cosine squared theta, and tangent would be sine squared theta over cosine squared theta. Since I have a fraction over a fraction, I can keep flip that. So I have sine squared theta over cosine squared theta times cosine squared theta over 1. And those two will cancel out, so I just get my sine squared theta. Okay, so that's using a Pythagorean identity first and then a reciprocal identity. I'm going to go ahead and skip part B because, and you can look it up in your book if you want to, But that's just the same process again, but using the reciprocal identity first. So probably changing, let's see, this secant squared part first, and then using the Pythagorean identity, but you're going to get the same answer. You're going to get that to simplify down to that sine squared. So they're just saying you can do it in different orders, and you can try different things. You'll end up with the same answer. So I'm not going to necessarily go through that one. Combining fractions before using identities. So again, we're going to start with the most complicated side first. We want to combine those by adding, so we want to find a common denominator. Those two denominators are not exactly the same, so what we're going to do is we're going to multiply this one by 1 plus sine of, that's alpha, over 1 plus sine of alpha. And we're going to do the same thing on this side, but we're going to multiply by 1 minus sine of alpha over 1 minus sine of alpha. So we're going to multiply this guy by this denominator and this guy by this denominator. So 1 times 1 plus sine of alpha is just going to give me that 1 plus sine of alpha. And then this 1 times 1 minus sine of alpha is just going to give us 1 minus sine of alpha. And I'm going to put it all under one roof. So 1 times this will give me this part. 1 times this will give me this part. And all of that on the bottom will give me, if I FOIL, do I want to FOIL? Yeah, I do. 1 times 1 is 1. 1 times sine of alpha is a positive sine alpha. Negative sine of alpha times 1 is negative sine alpha. And negative sine of alpha times its positive sine of alpha is a negative sine squared alpha. Okay? So things are, I'm really fuzzy, sorry. Things are going to cancel out really nicely for us. 1 and 1 will give us 2. And then sine of alpha and negative sine of alpha will cross out, so I just have 2 on the top. Okay? On the bottom, the sine of alpha and negative sine of alpha cancel out, and I have 1 minus sine squared alpha. Let me make that so it's not so fuzzy now. Okay, 1 minus sine squared alpha. If you look at our Pythagorean identities, 1 minus, if I subtract sine squared, that would be like cosine squared. 1 minus sine squared would be cosine squared. So this is 2 over cosine squared alpha. And then I'm going to do one more thing. Cosine squared alpha, when it's on the bottom there, this would be like saying 2 times 1 over cosine squared alpha. And 1 over cosine is secant. 1 over cosine is secant. So this would be 2 secant squared alpha. And that's how he would simplify. Oh, which is what this was right there. So that's what we're trying to get to. Next one. Verifying a trig identity. So what we're going to do for this one is, let's see, tangent squared x plus 1. That might be a Pythagorean identity. Yep, it is. Tangent squared x plus 1 is secant squared. So I'm going to write secant squared x in his place. Okay. Cosine squared minus 1. Let's see. Cosine squared minus 1. I know that sine squared is equal to 1 minus cosine squared if I move him to the other side. So if I want cosine squared minus 1, that would be like negative sine squared. So I'm going to do this, negative sine squared x. Okay. We want to try to get this guy right here to be negative tangent squared. All right, so let's see what we've got going on. Secant squared, okay, that is, secant is 1 over cosine. So this would be like 1 over cosine squared x. And negative sine squared is like negative sine squared x over 1. And what that will become is, if I multiply the tops and the bottoms, that's negative sine squared x over cosine squared x, and that becomes negative tangent squared x. And there he is. Okay, next one, converting to sines and cosines. So this one, they want us to take everything and reduce it down to sines and cosines. I don't know which side is uglier. Let's just go ahead and work with the, let's work with the left side. So tangent is sine over cosine. I'm going to get really lazy and forget to put my axes on. So whatever. Cotangent is cosine over sine. All right, and I want to get a common denominator, so it's going to be cosine times sine. So what I have to multiply this side by is sine over sine, and this guy has to multiply by cosine over cosine. So that's what he looks like. Since this one did not have a sine in the bottom, I have to multiply by sine. This one didn't have a cosine, so it's multiplied by cosine. So sine times sine is sine squared. Cosine times cosine is cosine squared, which is wonderful because sine squared plus cosine squared is 1. So this is 1 over cosine times sine, right? Now, we're almost done. 1 over cosine times sine is like 1 over cosine times 1 over sine. That's what that looks like. And 1 over cosine is secant, and 1 over sine is cosecant. And I'm going to put my x's back in there, so I have secant x times cosecant x, and there is how I get from the left to the right. Okay. If I went too fast through any of that, again, either get with somebody else in class and have them help you understand it, or rewind and watch this again. Okay. On the back side, working with each side separately. So what they want us to do on this one is simplify one side until you get to a place where it's really ugly. Oh, no, wrong. I'm looking at the wrong part here. We have one to do before that one. This one here, verifying a trig identity. All right, so let's start with the ugliest side. This time I'm going to start with the right side. Let's do that. Because I think he looks a little bit uglier than the left. So this guy right here, I don't have any squares, so I'm not going to do Pythagorean identity. They're both in sines and cosines already. So let's do something that we haven't done yet. This is this bottom down here is 1 minus sine of y. I'm going to use what's called the conjugate. And I know we've done this before. The conjugate, I'm going to multiply by the conjugate. And the conjugate of 1 minus sine of y is 1 plus sine of y. I'm going to multiply by 1 plus sine of y on both the top and the bottom. Okay, let's see if that gets us somewhere. So on the top, I will have, yeah, that's what I want to do. Cosine of y times 1 is cosine y. And cosine of y times sine of y is cosine y sine y. That doesn't really simplify very well, but that's okay. On the bottom, 1 times 1 is 1. 1 times sine of y is sine of y. Negative sine of y times 1 is negative sine y. And negative sine y times positive sine y is negative sine squared y. Okay, so this bottom piece is going to cancel out, and 1 minus sine squared of y is negative, let's see where I want to go with this, is negative cosine squared y. No, positive cosine squared y. From your Pythagorean identity. That's like the sine squared plus cosine squared equals 1. 1 minus sine squared is cosine squared. So now I've got that. Kind of thinking maybe I didn't want to distribute this through. I'm going to go back up to this step where I just had this piece and write it like that. So don't write it multiplied together, because I'm going to cancel one of those cosines out. This cosine will cancel with one of these. So I have 1 plus sine of y over cosine of y. And that can break down into 1 over cosine y plus sine of y over cosine of y. Well, 1 over cosine y is secant of y, and sine over cosine is tangent of y. And that's what we were trying to get to from the beginning. Okay? These are all like puzzles. Sometimes you do things and you don't want to do them, so you backtrack. Like this one, I did not want to multiply that through. And I found that out over here. It's hard to know what to do. You just kind of have to go with something until you get it figured out. Next example, work with each side separately. So this is what we're getting to. What they want us to do here is work with this side until you get to a spot, and then work with this side until you get to a spot. Okay? So let's start with the left side. Let's see if I can write small enough. Cotangent squared of theta. Since that's cotangent squared, let's go ahead and use the Pythagorean identity. Cotangent squared right here. If I subtract the 1 over, cotangent squared would be cosecant squared minus 1. So I have got cosecant squared minus 1 over 1 plus cosecant of theta. Okay, now, okay, this kind of seems a little far-fetched, but it's going to get us somewhere. Cosecant squared minus 1 is a difference of squares. It is cosecant theta minus 1 times cosecant theta plus 1. And at the bottom, I have 1 plus cosecant theta. 1 plus cosecant theta is the same thing as cosecant theta plus 1, so those cancel out. So all I have is cosecant theta minus 1. Okay, and I don't think there is any more that I can do with that. So what I'm going to do is I'm going to start with the right side now, work with it until I get down to cosecant theta minus 1. Let's see if we can get somewhere with that. So yeah, this part's really easy. 1 minus sine of theta over sine of theta, I can break that down into 1 over sine of theta minus sine of theta over sine of theta. 1 over sine of theta is cosecant theta, and sine of theta over sine theta is 1. So both of those match up, and I'm good. So that one was one that was really ugly. We had to work with both sides separately, right? Okay, these next three are going to kind of go fairly quickly, I think. What we've got going on here, verifying each identity. In this case, I'm going to start with the non-ugly side and show you how it turns into... do I want to do that? No, let's start with the ugly side. We'll start with the ugly side. Let's start with this side, okay? So I've got two pieces here, and I notice that there's a tangent squared x in both of them, so I'm going to break that out. Tangent squared x, I'm left with secant squared x minus 1. Secant squared x minus 1, if you look at your Pythagorean identity, that is a tangent squared x. So this is tangent squared x times another tangent squared x is tangent to the 4th power of x. And that's what I wanted to get to. Okay. This one right here, what I can do for this piece that's in parentheses, I can pull a cosine to the 4th power out, and that will leave me with 1 minus cosine squared x. And then I've got that sine of x hanging on to the end. 1 minus cosine squared x is sine squared x. And sine squared x times sine squared x is sine to the 3rd power of x with that cosine to the 4th on the front. And there we go. Okay. And this last one right here, in this parentheses here, I see that both pieces have a cotangent, so I'm going to pull that cotangent out. I'm just going to rewrite that cosecant squared so I remember not to forget him. But then I've got, I'm going to do a bracket here. Cotangent x times 1 plus cotangent squared x. 1 plus cotangent squared x is cosecant squared x. Okay. And cosecant squared and another cosecant squared is cosecant to the 4th, of x. And then I've got that cotangent x. And that's what I started with. So those ones went kind of quick. Always when there's two pieces, look to see if there's something that you can pull out in front, which was kind of what we did on all three of those. Okay? Oh, that was a long section. There you go.